And how much did it actually cost to build this collector?
Well, this collector, if you include all the costs, okay, so you include wooden box, the glazing, the collectors, the insulation, everything together, the aluminium collector cost us £266 to build. But, well, the stainless steel cost us £460, so quite a significant, difference as such. The cost of only this collector is about £160.
Right, not bad.
Not bad at all, aye. Another thing is, this is prototype costs. So then, if you put it into a production en masse, right, that will really much decrease the actual capital cost of these collectors.
Well, they look pretty bulky. Could they actually be fitted retrospectively to an existing building?
Yes, they could. Again, as I said, it's a prototype style. If they were to be fitted on a house, we'll find of better ways, really, of, aesthetically speaking, of making it. But again, if you speak structurally speaking, it's not a problem whatsoever, as the actual weight of the collector is not more than the actual tiles on your roof. So if you remove your tiles and you integrate the collector within your roof structure, then it wouldn't be a problem. And then you'll have a type of drainage system such as the one you have on the, the roof windows, or integrated flat plate collectors on roofs. So it's the same type of drainage systems. Yeah.
Right. And what are some of the issues with solar water heating in Scotland in this climate?
Freezing. Freezing is, I think, the most critical point for northern countries, colder countries as such as Scotland, really. But there are many ways companies now go around it, such as using, flexible pipes, as such.
It all just seems so straightforward. What stops people investing in these technologies?
People are investing in this type of technologies. Just to give you an idea, right, worldwide capacity increased by about 18% in 2008. So it starts, there is a take-up. UK alone, in between 2007 and 2008, increased their installed capacity for solar thermal by 50%. So there is a take-up. Now, as you said, there's still the inherent capital cost. And you have to put it up front, which is really I think the main barrier of this technology taking up even more as such. But you got many ways around it with grants now from our governments, and you got many, 0% loans as well for purchasing, low carbon technologies. And you have a new incentive actually, which is going to be available in 2011, and that will really shake the development, I think, of this type of technologies, and that's a renewable heat incentive. Don't know if you heard about it. Yeah, and that will really be a driving force. This incentive will be supporting all type of renewable heat technology, so really driving up, towards our targets for 2020. And really, I think this type of technology are the future, and they are part of the solution. They are part of the solution to meet our present needs without compromising, the needs of our future generation. And, that's the beauty of it, and part of the solution again.
Thank you very much.
You're welcome.
In order to calculate how much heat energy we can produce in Edinburgh, I've selected just any collector from a large manufacturer just to get an idea of its cost, its weight, its size. The collector that I chose was an evacuated tube collector costing £1,550 and with a claimed efficiency of 93%. I've used this price as the basis for the calculation, but clearly this would be reduced dramatically if the collectors were purchased in bulk. Using this data alongside our calculated available solar radiation, it was possible to estimate that each collector would produce 768 kilowatt hours per year. However, as Dr. Garnier's results showed, in a real-life situation, more energy than this can actually be produced. Once again, it's important to calculate how quickly the carbon emitted during manufacture would be paid back when the actual product was in use. The collector itself weighs 43 kilograms. If data was available on the weights of each component, that would give a more accurate answer, but by using information from similar studies, we can make a rough calculation that the embodied energy of the collector is 4.94 megawatt hours. This then allows us to make the important calculation around the emissions per kilowatt hour produced by simply dividing the total embodied carbon dioxide by the expected lifetime output. It's interesting to note that our answer of 0.086 kilograms of carbon dioxide per kilowatt hour is within the range of studies shown earlier and is less than half of the emissions of traditional gas heating and around a seventh of the emissions from oil heating. With all of this in mind, we can see that even in Scotland, solar water heaters are a technology that we can and should be investing in. They're available commercially at affordable prices, and with some knowledge and determination, as we saw earlier, you can make them yourselves.